So in this lesson, we're going to be looking at interval notation using inequality symbols and notation to represent values in a data set. So x is greater than 3 means that x is greater than. X is bigger than 3. So anything 3.1, 3.2, 4, 5, 6, 7, all those numbers that are bigger than 3. X is less than -1 means that x is less than. All right, now let's talk about open circle and closed circle. The first will be an open circle. An open circle is going to be used with the greater than symbol and the less than symbol. And for each of these, we're going to look at the numbers in the data set. So here, 3, 4, and 5. All right, this would mean that x is greater than 2. Okay, a closed circle. The closed circle symbols are going to be greater than and equal to with a line underneath, or less than and equal to with a line underneath. So this particular inequality, these numbers that are shaded are numbers lower than -4. So we need to use the less than or equal to since we have a closed circle here. All right, let's look at or. So you may have an inequality graph that's shaded in opposite directions. So here we have an open circle at 1, shaded for numbers smaller than 1. So this would be x is less than 1. Okay, or x is greater than or equal to 3. So because it's greater than or equal to, we need a closed circle here. All right, and we are shaded numbers bigger than 3. Okay, let's look at how to graph this. So we have x is less than or equal to 2. So I'm going to put 2 here. All right. Less than or equal to would be a closed circle here at 2, shaded to the left, because 1 and 0 and -1, these would all be on the left-hand side of 2. Or x is greater than 5. So here at 5, it would be an open circle, and these numbers to the right of 5, 6, 7, 8, and 9, all the way to infinity, would be shaded. Okay? And we're going to have an overlap between our inequality symbols. So we have x is greater than 2 and x is less than or equal to 6. This could also be combined, as we see here, with a 2 less than x less than or equal to 6. So we are only concerned with the overlap that is in the middle of these. So we have an open circle at 2, everything shaded to the right of 2, but we also have this and in there that says that it also has to be less than 6. So here at 6, the line stops, and so really we only have everything from here to here. And this is why we only have this one piece in the middle that's shaded. Okay, so let's look at this one. All right, we have that x is greater than or equal to -5, and x is less than -1, so open circle. And so x is going to be represented by everything in between. Okay, now let's look at these other graphs and let's see what information we can get from these. So a little bit of vocabulary using our intervals, using this interval notation. we're going to talk about a few things. So we're going to say that f of x, or the graph, is decreasing. So I'm going to do these in blue here. So f of x is decreasing when f of x is going down. So for us here on this graph, f of x, the graph is going down from left to right. All right, from the interval starting at negative infinity because of this arrow, and we're going all the way up until the value of x equals 1. So we're going from negative infinity until 1. Okay, we might also say that x is decreasing when x is less than 1. Okay, f of x is, I'll do this in purple, so the opposite of decreasing is increasing. F of x is increasing when the graph is going up. All right, so if our graph is going up like it is here, all right, at x equals 2 all the way to infinity, all right, from 2 to infinity, that is when our graph is increasing, or we could say that as x is greater than 2. Couple more things for us to notice. Notice I did not label this in the middle, all right, when the graph was not changing. So if it's flat, this is what we call a constant. So the graph would be constant from 1 to 2. All right, let's look at these other blanks that we have. So let's say, we're going to say that f of x is positive when we are above the x-axis. So again, here's our x-axis, all right, the horizontal line. So we are positive when we are above the x-axis. Okay, all of our y values are positive up there. All right, f of x is negative when we are below the x-axis. So anytime we fall below the x-axis, all right, f of x is negative. So when would these be positive and when would these be negative? Well, our graph is positive from negative infinity up until, we'll say, 1/2. All right, and then we're also positive at 3 to infinity again. And when are we negative? Well, at 1/2 we start to become negative, and then all the way up until 3. Our graph is in the negative side of the x-axis. All right, so let's answer these questions about our given f of x graph. So when is f of x decreasing? So when is our graph going down when looking at it from left to right? Well, here it's going up. It reaches its top point here. And then after x equals 0, our graph is going down. So when is this decreasing? Well, it's decreasing on this side of 0. So from 0 to infinity, our graph is decreasing, or when x is greater than 0. When is f of x increasing? Well, f of x is increasing on this side. All right, that is climbing the hill of this mountain for that parabola. And that's going to be the opposite. So from negative infinity to 0, or when x is less than 0. When is f of x constant? So there is no time here when f of x is constant. We're just going to put not any there for that. When is f of x positive? So positive means above the x-axis. All right, so that is going to represent above the x-axis. That happens from the interval from -1 to +1. Okay, or we could write that as -1 to +1. Okay, when is f of x negative? Well, that's going to be here and here. All right, so that is going to be from -infinity to -1. And then again, all right, we say the union from 1 to infinity. We could represent this with an or statement. We could say that x is less than -1 or x is greater than 1. That's the interval when our graph is in the negative range. All right, we're going to answer this one. So when is f of x decreasing? And you may want to take a second and pause the video, try this out on your own, see how you do. I am going to go over this question for us at the end, but go ahead and see if you can find the answer to this. So when is f of x decreasing? So the graph is going down. All right, that's going to be from -infinity to -2, and then also from 0 to 2. When is f of x increasing? Well, that's when the graph is going up. And so that's going to be from -2 to 0 and 2 to infinity. When is f of x constant? Well, there is not any instance when this is constant. When is f of x positive? Well, that's going to be for everything above the x-axis. And you might be thinking that, well, coach, that's everything that we have here. But at -2 and 2, it's actually equal to 0. And 0 is neither positive or negative. So f of x is positive from -infinity to -2, and then from -2 to 2, and then from 2 to infinity. Also, when is f of x negative? There are not any points when f of x is negative, because there are no points on the graph that are below the x-axis. Let's look at our last example. And again, I would encourage you guys to pause the video, try this out. Once you have tried, come back and see if your work matches what we're going to talk about here in the video. So the first question, when is f of x decreasing? So when is the graph going down? Well, here is the interval where it's going down from -infinity all the way until -4. And then again at 3 to infinity. So we have the interval from -infinity to -4 combined with the interval from 3 to infinity. When is f of x increasing? Well, that's when the graph is going up. And so that's going to be from -3 all the way until 1. When is f of x constant? Well, f of x is constant when the graph is flat here, and that's going to be from 1 to 3. When is f of x positive? So when is f of x above the x-axis? That's going to be from -1 up until 4. And when is f of x negative? This is when f of x is below the x-axis. So that first is from -infinity up until, what is that, -1. Union, and we have 4 to positive infinity. And again, we could write this with our interval notation that we looked at from the beginning. So this would be x is less than -1 or x is greater than